So I think last time we were talking about shear force and bending moment diagram. I have told you the basics, how to draw the shear force and bending moment diagram. I have told you about the relationship between shear force, bending moment and loading, and how we are going to use that equations to draw bending moment diagram and shear force quickly. I have also shown you the classical approach that we use while we evaluate the equations for shear force and bending moment diagram. But I have told you that we will go for shortcut method only. We will use those relations and we will draw the shear force and bending moment diagram. In this part of the lecture, the focus will be questions. Okay. I think last time we haven't solved any questions, so this time we'll focus on questions. So let's start with some basic problems. For example, this problem here. Suppose you have a cantilever, okay, and you are having a point load here, okay, point load at the end P. I want you to draw the shear force and bending moment diagram here. So I think it's a pretty straightforward question. Whatever I have told you in the last lecture, remember that and solve for shear force and bending moment diagram. Okay, this will be your shear force diagram and this will be your bending moment diagram. Okay, so this is your, suppose the length is given as L. Okay, so this is your 0 and this is your L. Okay, 0 and L. Okay, this is how you should draw it. Okay, so that you have a proper analysis. Now I want to find the reactions here. So I think you don't have any problem with this reaction. This is pre here, so the reaction that you will get here is P, and the moment that you will get here is something like this, PL. Okay, if you are not able to solve this, you go back to the first lecture. In the first lecture I have shown you how to solve for reactions. Okay, so shear force diagram. Okay, shear force diagram, you have P force here. P फोर्स ऊपर की डायरेक्शन में लगा हुआ है, ठीक है. जैसे ही तुमको कॉन्सेंट्रेटेड लोड P लोड मिला यहाँ पे, तुम अपने shear force diagram को ऊपर उठा दो P. Okay, now in the whole span you are not having any loading. Okay, I have told you the relation between shear force and loading is W is equal to dV by dx. Okay, in this whole span from here to here, okay, from here to here you have no loading, isn't it? So no loading means your W is 0 here. So W is equal to dV by dx. If you integrate, you will get shear force is constant, isn't it? Shear force is constant. You already know that at this point your shear force is P. Okay, so it will remain constant throughout, okay, up to here, and as soon as you reach this point, you are getting a downward force P, so you bring this point down by P, so it will come back to 0. Is this okay? I hope you are able to understand. So this is your shear force diagram. It is positive throughout. Is it okay? Now come to the bending moment diagram. Okay, come to the bending moment diagram. You see here, at this point you are having this type of moment. Okay, here you are having a moment of PL. So suppose just a small section, suppose I take for delta x length, what will be the moment here? In this direction you will have PL to counter this moment, isn't it? This moment you will have. Now I have already told you this is your left section, isn't it? Left section you are having clockwise PL, so it will be minus PL. Okay, sign you should be very careful about. It is negative of PL, isn't it? So here you are having something like this, okay, minus PL. Is it okay? Now you already know the relation between shear force and bending moment. V is equal to dm by dx. Your shear force is constant throughout, isn't it? It is constant, so your M will follow a linear relationship, okay, with positive slope, because your shear force is positive, and shear force is nothing but the slope of your bending moment diagram, so it will increase in positive direction from here to here. Okay, now my primary concern is what is the value at this point, because I have many possibilities, right? I can draw this diagram like this, okay, or like this, okay, or like this, something like this. Okay, it has positive slope, that's all I know. So I want to know the value at this point. Is it okay? I want to know the value at this point. So you have to evaluate bending moment at your free end. Okay, what is the bending moment at my free end? It is 0, isn't it? If you want to solve, you can solve here. See, I want to know the value at this point. What point? This point, B point say. So if you draw the free body diagram, you have one P force here, P force here, and PL moment here. Calculate the moment at this point B. What is the moment at this point B? This P will not give you any moment because it is passing through that point. Okay, this P will give you clockwise moment of PL, and this P is anti-clockwise of PL. So your net moment is 0 at B. Okay, your net moment is 0 at B. So now I can surely say that my bending moment curve will look something like this, isn't it? Something like this. Is this clear? Okay, so this is your bending moment diagram. Be careful that it is negative. Okay, it is negative. So this is your first problem, very simple problem. Okay, now moving forward, suppose we have a question like this. This is your second question. Suppose you have your beam like this. This is again a cantilever. Rather than having a point load here, you are having a moment m0. Okay, now I want you to draw the shear force and bending moment diagram. Is it okay? Here you draw the shear force diagram, and here you draw the bending moment diagram. Let's start. Okay, first of all, I want to know the reactions here. So what is this force here? It is 0. Okay, you don't have any reaction here because there is no loading here. So there is no reaction here. But to counter this moment, you will have one moment m0. Is it okay? Now let's talk about the shear force diagram. Shear force diagram is nothing but W is equal to dV by dx. Throughout the span, you are not having any loading, so your shear force will be constant throughout, isn't it? And what is that constant value? It is equal to 0, isn't it? Because there is no shear force, there is no reaction here, so your curve will not take any jump or anything. It will remain 0 throughout your span. Is that okay? I think you are able to understand. Last lecture, last part also, I think we did the same thing. Okay, moving on about the bending moment diagram. Okay, now think about it. Suppose I take a very small section here. Okay, from the left I am talking. I have taken a very small section here. This is m0. So if you see here, you are getting plus m0. Okay, sign is the only thing that is I am trying to show here. This is anti-clockwise on the left section, so you are having plus m0. So you will have plus m0 reaction here, and now you look at it. V is equal to dm by dx. Your V is equal to how much? It is 0. So your moment will be constant, okay, throughout the section. That means if it is m0 here, it's going to remain m0 and it will be constant. Is this clear? Okay, it is going to be constant. This is your positive. Is it clear? I think you are able to understand this. Let's move on to the third question. Slightly difficult questions you have to see. Okay, let's again talk about cantilever, but slightly trickier. Let's have UDL here. Okay, you are having some W amount of UDL here. Now I want to know what is the shear force and bending moment diagram are going to look like. Is it okay? Now first of all, I want the reaction here. What will be the reaction here? Suppose the length is L, so reaction will be WL. What is the moment here? It will be like this, and the value will be, okay, equivalent force you can apply, WL, and this will be L by 2. So what will be this moment? WL into L by 2. So it is WL square by 2. Is it okay? I think it is clear. Now let's start with the shear force diagram. Okay, shear force diagram. Now one thing I know for sure, that my W is equal to dV by dx. W is constant and it is a negative, so I am writing it minus C is equal to dV by dx. If you solve this, that is you integrate it, you will get V is equal to minus Cx plus C2. It is a linear with negative slope, isn't it? It is a line, straight line with negative slope. So what is the value at this point? It is WL positive because it is in the upward direction, right? So you just इसको उठा दो इस पॉइंट को यहाँ से WL ऊपर की तरफ, जिस डायरेक्शन में ये है, ठीक है। अब यहाँ से ये लीनियर इक्वेशन फॉलो कर रहा है नेगेटिव स्लोप के साथ, तो कुछ ऐसी लाइन आएगी तुम्हारी, ठीक है, ऐसी कुछ आएगी। अब ये ऐसी आ सकती है, ऐसी आ सकती है, ऐसी आ सकती है, वो तुम्हें देखना पड़ेगा कि इस पॉइंट पे वैल्यू कितनी है, ठीक है। बस नेगेटिव स्लोप की लाइन है, ये पक्का हो गया। अब अगर हमको इस पॉइंट पे वैल्यू मिल जाए शियर फोर्स की तो हमारा काम हो गया, ठीक है। सो व्हाट इज़ द वैल्यू एट दिस पॉइंट? ओके, think about it. What is the value at this point? Draw the free body diagram. Always draw the free body diagram. Okay, I want the value at free end B. Okay, this is your WL. You have one moment here, WL square by 2. Okay, and this is your free body. This is your free end, so it is not going to have any shear force. It is already 0. Okay, so no need to solve anything. You will get the value as 0 because it is a free end and there is no applied moment. So it is going to look like this. Your shear force diagram will look like this. Is it okay? It is positive. Is it clear? I hope it is clear. Okay, let's talk about bending moment diagram. Okay, let's talk about bending moment diagram. Now I know one thing, that my V, or rather, yeah, my V is equal to dm by dx, and V, as you know, is following linear equation. So my moment is going to follow x square type of equation. Okay, it's going to be a function of x square. That is, it is a parabola basically. Okay, it is a parabola, it is an upward parabola. Now what is the value at this point? Think about it. Draw the free body diagram from up to here. Okay, you will get, this is WL square by 2. Suppose this length is very small, so this load is not going to play that much effect, so it will be WL square by 2. If it is very small, delta x is nearly 0, I want to find out exactly at the support. Okay, so you can see here it is clockwise, so it is negative, so you will have minus WL square by 2 here. Are you clear about the sign? Okay, just take a very small section and draw what is the moment that is going to come at this section. If it is clockwise, it is negative. If it comes out to be anti-clockwise, it is positive. I hope you are able to understand this. Okay, sign convention, you should work it out on your own. Now I am telling you this is a parabola. At free end, at this end, you are having no shear force and no bending moment because it is a free end. Okay, you are not going to have anything. From here to here, okay, it is a parabola. Now many people get confused here. Okay, many people get confused here. Some people draw it like this. Okay, some people draw it like this. Okay, while some people draw it like this, which one is correct? Red one or the black one? Okay, think about it. Okay, whenever you are in this type of doubt that what is the curvature, whether it is this one or this one, क्योंकि जब ऑब्जेक्टिव आता है तो वो इसी में फंसा देता है, ठीक है। तो इफ़ यू आर इन कन्फ्यूजन दैट इफ इट इज़ 1 or 2, you look at the shear force diagram. Okay, you have positive slope, but your slope should reduce with distance, isn't it? As your x is increasing, your slope should reduce. This is nothing but the slope of your bending moment diagram, shear force, isn't it? So your slope should reduce, so your curve is a red one, not the black one. Is it okay? Because for the black one, the slope is increasing, it is not decreasing, but you can see from the shear force diagram, your slope should reduce with distance, and that is shown by this red curve, not the black curve. Okay, so one confusion, this is the one confusion that people have about curvature. Okay, so I think the confusion is clear now, and now you can solve this problem. I think we have done 3 questions. Move on to the 4th question. Let's have a little more practice. Okay, I think simply supported we have already solved. Let's quickly solve simply supported. Okay, we have done it many times. You have this roller here, suppose you have P here. Okay, now very quickly solve it. I think you know all the things about simply supported. We have solved it 2-3 times. Okay, so shear force diagram, if you draw, or first you calculate the reaction, this will be P by 2, you know, this will be P by 2. Okay, so this is P by 2 in upward direction, तो इस पॉइंट को 0 से उठा दो P by 2. ठीक है, अब यहाँ पे लोडिंग नहीं है, इस रीजन में लोडिंग नहीं है, मतलब तुम्हारा W 0 है, और w dv/dx होता है, मतलब तुम्हारा shear force कांस्टेंट रहेगा यहाँ पे, ठीक है। अब जैसे ये यहाँ पे आया, इसको ये डाउनवर्ड डायरेक्शन में p मिल गया, तो इस पॉइंट को तुम p नीचे ले आओ, कितना p नीचे ले आओ सीधा, ठीक है। अब ये यहाँ आ गया, अब इसको p नीचे लाए हो तो ये कितना हो गया होगा p/2। फिर इसको इस रीजन में भी तुम्हारे पास लोडिंग नहीं है तो ये फिर कांस्टेंट रहेगा, और फिर इसको p/2 मिल जाएगा आखिरी में, तो ये वापस 0 पे आ जाएगा यहाँ पे। दिस इज अगेन योर p/2। आई थिंक यू आर एबल टू अंडरस्टैंड दैट दिस इज पॉजिटिव एंड दिस इज योर नेगेटिव। इज इट ओके? Bending moment diagram you can draw from this equation, v is equal to dm/dx. Here, okay, you are having zero bending moment, you know, here also you are having zero bending moment, okay. Now here you are having positive constant slope, that means it is linear, okay, so it will go like this, okay. Then it has negative slope and linear, so it is going like this. We have already done this. This value will come out to be PL/4, okay. This is your bending moment diagram and this is your shear force diagram. I think things are clear now. Let's solve one more simply supported question. Okay. Suppose you have another simply supported beam. This time instead of having a point load, okay, a point load, you are having UDL. Say it is W. Okay. You have to draw shear force and bending moment diagram. Is it okay? Now first you calculate the reaction. This will be WL/2, okay, this will be WL/2. Is it okay? This is say point A and this is say point B, okay. Now when you are drawing shear force diagram, you know W is equal to dv/dx. Now W is constant, negative, so I am writing it minus C. C is a constant and negative sign because your loading is having downward direction, isn't it? So minus C, so your shear force will be minus Cx plus C2. That is, you don't have to solve and get this equation, okay, there is no need. You just get the idea that it is a line, it is a straight line with negative slope. Is it okay? And the value of slope is W, okay. तो इस पॉइंट पे जैसे ही तुम आओगे तो तुम्हें प्लस WL/2 मिल गया ऊपर की डायरेक्शन में, तो तुम इसको WL/2 उठा दो ऊपर की डायरेक्शन में। अब यहाँ से स्ट्रेट लाइन है नेगेटिव स्लोप की, ठीक है। अब ये स्ट्रेट लाइन है नेगेटिव स्लोप की, तो ये ऐसे आ सकती है, ठीक है, ये ऐसे भी आ सकती है, ठीक है, ये ऐसे भी आ सकती है। तो ये डिपेंड करेगा तुम्हारी इस वैल्यू पे, ठीक है, बी पॉइंट पे वैल्यू पे। तो तुमको पता है कि बी पॉइंट पे कितनी वैल्यू है, WL/2, ठीक है। अगर तुम ये इसका फ्री बॉडी डायग्राम बनाओगे, जस्ट यहाँ पे पता करना है हमें कितनी वैल्यू है, तो ये कुछ ऐसी आएगी, ठीक है। तो यहाँ से तुम्हें दिख रहा है राइट सेक्शन पे नीचे क्या होता है, नेगेटिव होता है, तो इट इज़ minus WL/2. Let me explain this more clearly. Okay. See, what I am telling here is, now your shear force diagram, you are saying it is a straight line with negative slope. अब वो straight line ऐसे भी जा सकती है, ऐसे भी जा सकती है, ऐसे भी जा सकती है. You have three possibilities, isn't it? Now all depends on the value of shear force at point B. Okay, everything depends upon value of shear force at point B. What is the value of shear force here? Okay, what is the value of shear force here? If you draw the free body diagram for a very small distance, okay, very small distance, I have taken a section just close to this support. So you are having your reaction here WL/2. Okay, so to oppose the reaction you will get WL/2 in this direction. Okay, now revisit your sign convention. Okay, your sign convention is like this. This is positive and this is positive. Okay, isn't it? This is positive. Now you look here, this is positive in the upward direction on right section, but you are getting in the downward direction, so it will be minus WL/2. Is it okay? So here your value is minus WL/2, and you know in between you are having a straight line. So this is your shear force diagram. This is your positive and this is your negative. Okay, is it okay? I hope you are able to understand. Just people get confused in sign convention, so be careful about the sign convention. Now let's talk about bending moment diagram. It is very simple. A point is pin joint, so you are having zero bending moment at A point. B point is roller, again zero bending moment at B. Okay, so it is 0 here and 0 here. Okay, now your V is equal to dm/dx. Your shear force is positive slope and reducing slope. Okay, So you obviously know your V is linear, isn't it? It is C1x plus C2 is equal to dm by dx. So your moment will follow x square relationship, C1x plus C2 plus C3. This type of relation it will follow x square. X square is parabolic, so it is going to follow parabolic relation. Slope is positive in this half, okay? In the first half, this half, your slope is positive and reducing, okay? And it is a parabola, so it will be like this, okay? Slope is positive but it is reducing. After this time, slope is negative and it is increasing, so it will be like this, okay? It's going to be a parabola like this. Is it okay? It will be positive entirely. This is your bending moment diagram. I hope you are able to understand. Moving on to the next question. Okay, let's solve a question on triangular loading also. Let's solve a question on triangular loading. Okay, I think it is your 7th question, right? So you have a cantilever, something like this, and you are having a triangular loading. Okay, here it is 0. It is something like this. Okay, downward direction, cantilever of length L. This is your W. Okay, now I want to draw the shear force and bending moment diagram. Okay, let's start. Here you will draw shear force diagram, here you will draw bending moment diagram. Let's start. SFD, and this is your BMD. My first job is to calculate the reactions, isn't it? What is the reaction here? Okay, suppose if it was a UDL, okay, it was a UDL, it will look like this. So it is nothing but half of UDL. If it was UDL, you will get WL here, okay, but it is half of WL. Okay, if you are not comfortable with this type of approach, what you can do, you can equate it with an equivalent force. What is your equivalent force here? It will act somewhere here, and the value will be WL by 2, isn't it? And it will act at a distance of how much? CG पे एक्ट करेगा ट्राइंगल के. ट्राइंगल का CG कितना होता है? 1/3 पे होता है, तो L by 3 पे एक्ट करेगा यहाँ से. ठीक है, ऐसे भी कर सकते हो. इस ट्राइंगुलर लोडिंग का इक्विवेलेंट निकाल लो. इक्विवेलेंट कितना है? WL by 2, और उसको लगा दो उसके CG पे जो L by 3 पे लोकेटेड है. ऐसे भी कर सकते हैं. ठीक है, तो रिएक्शन कितना आ जाएगा? रिएक्शन विल बी WL by 2 and you will have a moment also. What is the value of moment? It will be WL by 2 into L by 3. So you will get, I think you will get WL square by 6. Is it okay? WL square by 6 and reaction is WL by 2. Let me draw it smaller. Okay. Now let's start drawing the shear force diagram. So you are having a WL by 2 in the upward direction, तो इस पॉइंट को 0 से उठा दो WL by 2. ठीक है, अब आगे का तुम्हारी इक्वेशन डिसाइड करेगी. W इज इक्वल टू dV by dx. अब तुम्हारा W कांस्टेंट नहीं है, W लीनियर है और रिड्यूस कर रहा है. ठीक है, पहले तो वो नेगेटिव है और वो सब कुछ ऐसा है C1x माइनस C1x प्लस C2 टाइप का है. ठीक है, अब अगर तुम इसको इंटीग्रेट करोगे तो तुम्हारा V जो आएगा वो कुछ ऐसा आएगा, माइनस C1x स्क्वायर प्लस C2x प्लस C3. ओके, इक्वेशन से हमें मतलब नहीं है, हमें सिर्फ इतना देखना है कि ये पैराबोलिक है, मतलब हमें कर्व बनाना है पैराबोलिक. ओके, और उसका नेगेटिव स्लोप है. ठीक है, नेगेटिव स्लोप है, तो ये तुम्हारा जो कर्व बनेगा, ठीक है, वो दो टाइप से बना सकते हैं. दो टाइप से लोग बनाएंगे इसको. ठीक है, एक लोग कहेंगे कि चलो ऐसा बना देते हैं. ठीक है, पैराबोलिक, स्ट्रेट लाइन नहीं है, दिस इज नॉट अ स्ट्रेट लाइन, इट इज़ अ पैराबोलिक. ठीक है, तो वन ग्रुप ऑफ पीपल विल से दैट आई वांट टू ड्रॉ इट लाइक दिस. आई होप यू अंडरस्टैंड. ओके, एंड अनदर ग्रुप विल से दैट आई वांट टू ड्रॉ इट लाइक दिस. Which one will you choose, the red one or the green one? Let me draw this a little clearly. Okay, something like this. Okay, and the red one is like this. So you have two possible parabolas. It can be the red one or it can be the green one. Which one will you choose? Okay, it is very simple. See here, W is nothing but the slope of your bending moment diagram. W is reducing with your x, isn't it? As x is increasing, your W is reducing. So the slope of your shear force diagram is reducing with distance. Which one is showing the reduction in slope? Green one. Okay. So similar to the last case, we can tell that this red one is not your answer, the green one is your answer. Okay. This is what your shear force diagram will look like. Okay. Here bending moment diagram. Okay, next is bending moment diagram. You are having WL square by 6 in clockwise direction, so it will be minus WL square by 6. अब ये कौन सा कर्व फॉलो करेगा? V होता है तुम्हारा dm by dx. V तुम्हारा पैराबोला है, ठीक है. अब तुम अगर इसको इंटीग्रेट करोगे इसे पुट करके, तो m जो आएगा तुम्हारा वो क्यूबिक आ जाएगा, isn't it? Your m will come out to be cubic. Okay, cubic equation will come. At this point it is obviously a free end, so you are going to have zero moment. Okay, so you will have parabola like this. Again you can have confusion if I want to draw it like this or like this. So you see the shear force diagram. Okay, you see the slope is positive and it is reducing with distance, so your slope should be positive but it should reduce, so you will have this type of curve. This is your bending moment diagram. I hope you are able to understand this triangular loading. Okay, I think we have solved the basic questions that we require for structural analysis. Okay, rest we will see in strength of material only. I think for now this is enough. Let's solve one last question so that you get enough confidence that you can solve any problem on drawing bending moment and shear force diagrams. Okay, so the question is something like this. You have a simply supported beam like this. Okay, you have pin joint here and a roller joint here. Okay, and then you have loading of concentrated loading of 600 kilonewton here. Okay, and you are having at some point here you are having a clockwise moment of 4000 kilonewton meter. Okay, the distance is given to you. This distance here, this distance is 10. Okay, this distance is 5 and this distance is again 5. Okay, for this question you have to draw the shear force, draw the SFD and BMD of the beam. Okay, you have to draw the shear force and bending moment diagram of the beam. Let's start. Okay, here you can draw your shear force diagram, here you can draw your bending moment diagram. Okay, always draw it like this, just below the normal beam. This will be your SFD and this will be your BMD. Okay, what is my first step? What is my first step? My first step is to obviously calculate the reactions, isn't it? That is why I took that first lecture on reactions, how to calculate the reaction. So I think you are very much aware that, suppose I have already told you this, I am just revising for you. Suppose you have a beam like this, okay, and you have P loading here and it is simply supported. Okay, this is A distance, this is B distance. Okay, what is the reaction that comes here and here? I think I have told you this already in the first lecture. This will be PB by L and this is PA by L. L is the total distance. Okay, L is your total distance. Moment also I think I told you in the first lecture. Okay, suppose this is your moment, 4000 this is. Okay, or rather I am calculating for M, suppose. Okay, if this is your M, what is the reaction that you get here? I think you get positive reaction here and you will get a negative reaction here because they have to be equal and opposite. Okay, so you will get this value as M by L and this value as M by L. Okay, is the given question a combination of these two? Okay, So if you can remember these values, I have already told you in first lecture, you should be remembering these values. Okay, there is no point that you should be deriving them in the question paper. You will absolutely lose 5-10 minutes. So you should be able to remember these general cases. Okay, this is m by l. So you can directly calculate the reaction here. Okay, I am directly writing the reactions. Let me use green color. Suppose I am writing the reaction here and here. What is the reaction here? Left one. This 600 will produce a reaction equal to 600 into 10 divided by 20. Okay, are you able to understand this? It is nothing but PB upon L. PB upon L I am writing. Okay, so it is 600 into 10 upon 20 plus this moment will producing a reaction m by L, isn't it? So I am writing m by L. M by L is nothing but it is 4000 upon 20. Is that okay? Okay, now you have made a mistake. The direction is downwards, so you have to subtract it, isn't it? You have to subtract this because this moment is going to produce a downward reaction. Okay. Come here. So here you will have 600 into 10 divided by 20, isn't it? Plus m by L, this m by L, 4000 divided by 20. 4000 divided by 20. What is the value that is coming out here? I think it is coming out to be, okay, I think we have to shift it a little down, or rather I am writing here. Okay, you understood what I have written here. Okay, so the value that will come out is 100 here. Okay, and the value that will come out here is 500. Okay, use this anecdote. Okay, use this anecdote. Now you know the reactions. Let's start drawing the shear force diagram. It is very interesting. Okay, when you are drawing the shear force diagram, okay, let me use black. You are having 100 in the upward direction, so सीधा सीधा ये जो point है इसको उठा दो 100 vertically. जैसे ही तुमको 100 मिला ऊपर की डायरेक्शन में, तुम 100 ऊपर उठा दो. जैसे ही कोई concentrated load मिलेगा नीचे की डायरेक्शन में, तुम नीचे ले आना. ठीक है? So in this span from here to 600, you are having no loading. No loading means constant shear force diagram, isn't it? Constant shear force diagram is shown like this. Okay. Now as soon as you came here, you encountered this 600 kilonewton in the downward direction. Okay. So it will pull this shear force diagram in the downward direction like this, isn't it? Okay. If you want to know the value, this is 100 and this has brought down from here to here, it is 600. Okay, from here to here it is 600. So what will be the value here in the downward direction? I think it will be 500, minus 500. Okay, because this total has to be 600. Now from 600 to this moment, again you are having no loading, so again your shear force will remain constant. So from here to here it is again constant. Now think about it. Will this moment affect your shear force? Will this moment affect your shear force? It will not. Okay, it will not affect your shear force. Moment can never affect your shear force. It cannot induce a vertical reaction, isn't it? So what you can do is you can simply continue here. As soon as you reach here, you will get this 500 in the upward direction, so you can bring back it to 0. Is this clear? This is positive and this is negative. I hope you are able to understand. Let me shift this downward. Okay. So I think our shear force diagram is complete. Let's think about bending moment diagram. Okay, let's think about bending moment diagram. What is the bending moment here and here? It is pin joint and roller, so obviously the value is 0 here and obviously the value is 0 here also. Okay, now I know one relation, V is equal to dm by dx. Here, from here to here, my V is constant, shear force is constant, so I will have linear bending moment diagram, okay, with positive slope. So it will increase from here to here, isn't it? Here to here it will increase. What is the value here? That is my question. My question is, what will be the value here? Okay, so you can solve by many methods. Okay, you can draw the free body diagram. I am rubbing all this thing. Okay, what you can do, I think in last part I have told you one technique on how to calculate the bending moment, but what I can do, I can directly draw the bending moment or free body diagram. Okay, draw the free body diagram. Okay, I want to evaluate moment at this point 600. So you have 100 here, okay, you have 10 here, okay, so what will be the moment here? It will come something like this, 1000. Okay, 1000. So this is 1000. Okay, after this you have negative constant slope, so your bending moment will be linear. Okay, it will be linear. Now what should I do? Should I go right from here to here, or should I go like this? Okay, it is 0 at this point, so it can be like this and then go to 0, or it can directly go to 0. Okay, so that will be decided by this moment, this 4000 moment that is acting here. Okay, this will decide. So first let us go up to this point. Okay, from here to here. Okay, so from here to here you are having negative constant slope. Okay, what is the value at this point? I want to know. X, I am saying this section, what is the bending moment? Again draw the free body diagram. This is your 100 here, this is 600 here, this is 10, isn't it? I want to know the bending moment here. What will be the value? And this is your 15. Okay, so I think you will get 100 into 15 is how much? This is 5. Okay, this is 5. So you will have 100 into 15 is 1500, and this is 3000, isn't it? So I think you will get like this, minus 1500. Okay, 3000, 600 into 5, 3000, minus 100 into 15. How much you will get? 1500, and the direction is this one. Okay, because 3000 is bigger. Come back. Now here at this point somewhere here you are having value of minus 1500, and you know that the curve that is followed is linear because you are having constant shear force. I hope you are able to understand this. Okay, at this point something is happening that many people miss out. Okay, at this point, that is where this concentrated moment is acting. You are getting, suddenly you are getting a positive moment of 4000, positive moment of 4000, constant positive moment of 4000 suddenly you are getting at this point. So you have to increase it. Okay, increase it like this, something like this, and it will reach a value of how much? 1500, and this total rise is 4000, so this has to be 2500. Are you able to get it? 2500 plus 1500 is how much? 4000. I want to increase it suddenly by 4000 positive. Okay, so it has been increased by 4000. Further, your shear force is still negative. Okay, so it will come down like this. This is positive, this is negative, this is again positive. This is your final bending moment diagram. I hope you are able to understand this. Okay, if you want, you can pick up that Hibbler book and solve a couple of questions on free body diagram and drawing shear force and bending moment diagram. It will certainly help you. Okay, but I think I have told you most of the things. If you apply your mind, okay, solve it on your own once, you will become fluent in drawing these type of diagrams. So in next lecture I think we will start with calculation of deflection. Okay, thank you.